triangles. Okay, special white triangles. The first one I'm gonna introduce this special triangle. It's called 45, 45, 90 white triangle. Okay, you can see this is a white triangle, means one of the degree is gonna be 90 degree. Okay, and the rest of the two here is gonna be 45 degree and 45 degree. We call this as one of the special triangle. I need you guys remember this picture. Okay, I'm gonna explain it later. Okay, let me do the work first. Hold on. Okay. This special white triangle, I have a 90 degree and 45, 45 degree. And you could see what kind of the triangle is it? Except this is a white triangle. What kind of the triangle? What types of the triangle it is?
Equilateral. I'm sorry, not the other one, not scalene.
Isosceles.
That one.
Isosceles triangle. Remember what's an isosceles triangle?
The sides are equal.
The sides are equal. Two sides are equal to each other. Remember from the previous sessions, we learned the isosceles triangle. These two sides is equal, right? They're congruent for these two sides. And if these two sides are congruent, these two angles is also congruent. Okay, so this is a special type of the triangle. This is a white isosceles triangle. So you can see this A, this is the side here is A. So this side is also A. And then this is a 45 degree and this is also 45 degree. Okay, by looking at this triangle, can you guys find the length of the hypotenuse? Can you guys find the hypotenuse? Remember the formula? Pythagorean theorem. A squared plus B squared equal to C squared. Right? Can you guys plug in? I assume these two sides are the A. Using this formula, find out the hypotenuse in terms of the A. Okay, plug it in. The A and A here, find out what is the hypotenuse. What is your C equal to?
A squared plus A squared.
Okay. Okay, so we plug it in. We have a C squared equal to A squared plus A squared. So that would be C squared equal to A squared, right? And then we're gonna take the square root for both sides. So you should find C equal to A squared root 2. Okay, right? So now I have this triangle. If I have a special 45, 45, and 90 white triangle, I would remember if these two sides is going to be aligning with the A, and the hypotenuse, that would be A square root of 2. Okay, I need you guys write it down on your paper. I need you guys remember this one. Okay, we're gonna have another special triangle. Okay, this is the first one, 45, 45, and 90. Remember the side, A, and the hypotenuse is gonna be A square root 2. Okay? Okay, now let's look at the film. So film 5.5.1 in the white triangles whose angle measure 45 degree, 45 degree, and 90 degree. The legs are congruent. Okay, the legs is talking about these two sides. These two sides are congruent. And the hypotenuse have a length equal to the product of square root of 2. Okay, this is assuming like A equal to 1. Okay, if I draw this triangle here, (45, 45), we're supposed to have A, and A square root 2. If I let A equal to 1, so this, the leg is become 1 here, the leg is become 1 here. And 1 times square root 2 is going to be square root of 2. Okay, sometimes I will remember this triangle instead, okay? But it's for you guys, you could just add the A in here. So this is one of the film, okay? Remember this triangle. If you guys going to take trigonometry, calculus, you always miss this triangle, okay? Especially the trigonometry. Okay, let's look at this example. Find the length of the missing sides in each triangle. So look at this triangle. This is a 45, 45, and 90, right? And then it missing like the hypotenuse. So I want you guys, don't use the film, okay? I want to use this triangle. Plug in the numbers. Tell me what is your hypotenuse equal to. First, figure out what is your A equal to. What is your A equal to?
5.
5. Good. This is a 5, 5, right? And this is 8. So first one, you just write it down A equal to 5. And then the hypotenuse should be equal to A square root of 2, right? So you know A equal to 5, you could just plug it in. So AB, the segment AB equal to 5 square root 2. Okay? Okay, now I want you guys try to do the B, part B. Okay, B. This time, I have the hypotenuse equal to 6, right? I need to find out these two sides here. Okay, first figure out what is your A equal to. Okay, think about it. This one is pretty obvious. A equal to 5, right? But this one, I only know the hypotenuse, right? These two sides supposed to be congruent, right? So I'm gonna set it up 6 equal to a square root 2. Okay, C is talking about like this side here. Okay, so 6 equal to a square root of 2. And then I want to figure out what is my a here. So I'm gonna divide it by the square root 2 for both sides. You should get this done. Okay. Hey, remember for the algebra class, we don't want to have any radical on the denominator. How can I get out of this then? I don't want to have any radical on the denominator. What can you do?
Rationalize it.
Rationalize. How can you do rationalize?
Multiply by square root of 2 over square root of 2.
Good. Over times square root 2 over square root 2. Okay. So on the top numerator, 6 times square root 2 over square root 2 times square root of 2. This is just means square root 2 squared, right? So you cancel out the radical with the square, you're left with the 2 here. And then simplify. Divided by 2, divided by 2. So you should get your final answer, a equal to 3 square root 2. Do you guys get that? Okay, hey, one more time. In the math class, we don't want to have any radical on the denominator. So we try to do the rationalize, okay? Multiply the same square root numbers on the denominator. You should cancel out the radical. And then simplify it, you're gonna get a equal to 3 square root 2. Okay, we are not done yet, right? We want to figure out these two sides here. After we find the a equal to 3 square root 2. So these two sides, these two legs should be equal to a. So a equal to 3 square root 2 here and 3 square root 2 here. Okay. Okay, one more time. This is the example for the 45, 45, 90 special triangle. I need you guys remember all these three sides. Okay, a square root 2. Now, I'm gonna talk another one, another special triangle. That's called 30, 60, and 90. Okay, 30 plus 90 plus 60 will be equal to 90. 90 plus 90 is going to be 180. Okay, so we have another special triangle, 30, 60, and 90 triangle. Okay, in a right triangle, whose angle measures 30, 60, and 90, the hypotenuse have a length equal to twice the length of the shorter leg. So we have this triangle, we have the shorter leg, and this is the longer leg. And they say the hypotenuse, this side, has a length equal to twice the length of the shorter leg. So if this is A, how can you call your AB here? If BC equal to the A, the hypotenuse, that will be equal to 2A. And then they say, and the length of the longer leg is the product of the square root 3 and the length of the sorted length. So square root 3 of the sorted length. So square root 3 here. So from the theorem 5.5.2, I could draw the triangle. From this field, okay, this is gonna be the 60 degree, 30, and here I say if this is A, this is gonna be 2A here, okay? Twice the length of the sorted leg, and the longer leg is the product of the square root 3 and the length of the sorted leg. So this is gonna be A square root 3. Okay, so by the field 5.5.2, I should have this triangle. And again, write it down. You guys need to remember all these numbers, all this picture here. Okay, A with the 60 degree here, and then the hypotenuse is going to be 2A. The opposite side of the 60 degree, this longer leg will be A square root 3. Okay, now we try to prove this field. Okay, we're gonna use the picture proof. Okay, let's do it together, this one. So given triangle ABC with the angle A equal to 30 degree, angle B equal to 60 degree, angle C that will be the 90 degree, and BC equal to A. We're gonna prove AB, this side will be equal to 2A, and AC that will be equal to A square root 3. Okay, we want to prove this field. So this is all our given information here. So what can we do? First, I will draw another exactly the white triangle next to this guy. Okay, try to draw the picture with me, okay? Okay, your notes is missing here. So we're gonna draw exactly the same triangle next to it. So that will be 30 degree, 30 degree, 90, 90, and 60 and 60. Okay, draw the triangle first. Okay, so I know this side here, the BC will be equal to A. First, I want to know what types of the triangle is it with the ABD?
Equilateral.
Equilateral. Okay, what does the equilateral means?
Oh, I mean equiangular.
Equilateral and also equilateral. No. Yeah, it's not equilateral, right? What is the triangle?
Well, it's
No.
equiangular, but equiangular triangles are also equilateral.
Equiangular and equilateral should be, right?
Yes.
Because this is a 60 degree, total is 60 degree, 60 degree, and 60 degree. So meaning that first, if BC equal to A, what is the length with the CD? What is this length here? If this
Same as
is
A.
same as A, right? So means like the total length, the BD here is gonna be 2A. And we know this is a equilateral. So this is, they do have the congruent side. This side should be congruent to here, congruent to here. If this is 2A, AB should be equal to 2A. AD is also equal to 2A. Am I right? Okay, all sides are congruent. So you know AB equal to 2A and AD is also equal to 2A. Equiangle and equilateral, right? So we have the AB here equal to 2A. And actually AD is also equal to 2A. So we prove part of it, AB equal to 2A. Now we want to prove the AC equal to A squared root 3 here. Okay, so we prove the first part, we know AB equal to 2A. We want to prove the AC. So again, I want you guys to use this formula. Plug it in, you know this AB, you know the BC. Try to find the longer leg, try to find the AC. Plug it in to see what you guys get. Plug it in. So you should have 2A squared will be 4A squared, right? And then subtract the A squared for both sides. Subtract the A squared. And then take the square root. Okay. So you should get AC equal to A squared root 3. So we prove that AB equal to 2A, AC equal to A squared root 3. Okay. Okay, one more time, need you guys remember the two triangle. One is the 45, 45, 90. One is a 30, 60, and 90. So you have a square root of 2, a square root of 2. Okay, remember these two triangles. Okay, okay. So now you have another one, another 30, 60, 90 triangle. Make sure you don't mess up like the side in here, okay? You should remember like the 30, the angle measurement 30 degree, the opposite side is gonna be 8. So look at it like this way, 30 degree, opposite side is gonna be 8, 60 degree, opposite side is gonna be 8 square root 3. 90 degree is gonna be 2a. Remember one of the films saying that if you have the larger degree of the angle, the side should be longer. So you could remember like this way, 30 degrees is the smallest angle among the three. So the shortest line should be A here. 90 degrees should be the bigger angle compared with these two. So the longest side is going to be 2A. Okay, and A square root 3 is going to be in between these two numbers. So it's going to be opposite to 60 degrees. Okay, we talk about this film, right? Okay, this is these two special triangles is from the film 5.5.3 and the 5.5.4. One more time, remember this, and remember this. You need it for your test for sure. Okay, hey, your notes is missing like the degree here. I need you guys write it down all this information. Okay, the angles and the length of the side of the triangle. Okay, copy these two triangles on your notes. Okay, there's a missing here. Fill it in on your notes. Okay, let's do this example. White triangle DEF with the angle F 30 degree, EF equal to 12, and find the DF and the DU. Okay, I want you guys try to do it by yourself. First, figure out what is your A equal to. Okay, after you find A, plug in back to this side to find out the DE and the DF. Figure out the A first and then plug it in. Okay, first, what did you guys get for your A equal to?
6.
6. Okay, you just said 12 equal to 2A, right? 12 equal to 2A, and then divided by 2 for both sides, you should get A equal to 6. And then you're gonna plug in back here. So be careful, this is the 60 degree, okay? And this is 30. And this is 30 and this is 60. It's kind of like opposite angles in here. So your your DF here is opposite to the 60. So it should be 6 square root 3 here. And then the DE here equal to 6. Okay, make sure you didn't mess up these two sides here. Okay, DF, write it down on your triangle here. DF equal to 6 square root 3. And DE, that will be equal to 6. Got that? Okay, right? Every time if I give you guys this kind of the questions, try to write it down your special triangle with all this information first, and then try to compare side by side. First, figure out the A, and then you should be able to find out the rest of the side here. Okay, if you're done, try to do the example 4. Okay, if you're done, try to do the example 4. Okay, this one. Okay, they combine these two special triangles together. They only given like the MP equal to 3. So you need to figure out all this side here. Okay. So first, figure out this triangle. You know 60, okay, 60 degree, that would be 3. So A equal to 3. Okay, just compare with this triangle. So you find A equal to 3 here. Got that? Okay, what is your NM equal to?
6.
6, right? A equal to 3, you plug in here, 3 times 2, you're gonna get 6. Now figure out MP. Okay, MP. So MP equal to A square root 3. So your A is equal to 3, so that will be 3 square root 3. Do you guys get that? Okay, right, so far? Okay, now, you know this sign? Look at the 45, 45, 90 degree. So this is gonna be equal to your A here. Okay, this is gonna be equal to your A. So A equal to, for this triangle, for the 45, 45, 90 degree, the A is equal to 3 square root 3. Okay, separate into two. Okay, the on left hand side here, this is for the triangle 30, 60, 90. On the right hand side here, this is for the triangle with 45, 45, and 90. So in this triangle, A equal to 3 square root 3. So same idea with the PQ, right? PQ is also equal to the A, equal to 3 square root 3. Okay, right, so far? Now, the last one, the hypotenuse, that will be A square root 2. So you're gonna plug it in, MQ equal to A square root 2, and your A equal to 3 square root 3. Simplify it. So you're gonna get MQ equal to 3 square root of 6. Got that? Okay. And one more time, this two triangle is really, really important. Especially, I know some of you guys gonna take the trigonometry after the geometry class. You always need this triangle. Oh, you're right. Yeah, you're right. Thank you, thank you. I'm not done yet. I still have the NQ, right? NQ. NQ, that will be sum of these two parts, right? The 7 addition. So MP plus PQ. So we just add it up, 3 plus 3 square root 3. Okay. Question? Okay, one more. You guys have a one more? I didn't see it from the notes. You guys have this question on the notes?
No.
No.
Let me see. Yeah, I think I may miss this one though. Okay, can you guys just write it down on a piece of the paper? Copy this question on your notes. I'm missing like this one. I don't know why. The last example. Okay. So given in a triangle ABC, the way AD bisect BAC. Okay. By AD bisect BAC. And then AB equal to 20, AC equal to 10. Find DC, that small triangle here, DC, and the DB here. Okay. So you guys try to do it by yourself. And then we're gonna check the word together. I give you guys a hint. Think about it. What is the angle of BAD? What is the angle for BAD here?
30.
How do you know?
AD bisects BAC.
Good. AD bisect BAC, right? So it means like you're gonna divide it into equally. Divided the angle equally here. So this is 30 degrees, this is gonna be 30 degrees. So if this is a 30 degree, okay, what types of the triangle with the ABD?
Isosceles.
Isosceles triangle, good. Right, ABD here, this is a isosceles triangle because this is 30 degree, this is 30 degree, meaning that BD will be equal to AD here. So if you want to find the BD, you just need to find the AD here. Okay? Okay, try. You guys figure out the A. Find out the A first. What is your A equal to?
A is 10. Wait, I think for talking about DC.
You don't consider the triangle ABC, okay? Try to think about the triangle ADC. Think about
A equals 10 square root 3 over 3.
Good. I know this is a 30-degree as well, right? Because this is gonna be bisect. But think about if at the beginning, if you only, this is 30. So you could say this is a 60-degree and this is 30-degree. You could compare strictly with this triangle. Okay, if I only look at this one, AB is the hypotenuse. This side is also the hypotenuse. You could set it up to A equal to 20 and then A equal to 10. Okay, this is good, but think about it. If after you figure out A equal to 10, you only can find out the side of the BC, the whole length here. That will be 10 square root 3, right? But we are not looking for the BC. What we are looking for? We want to find the DC and the DB. Okay, so after I figure out A equal to 10 and I only can find BC equal to 10 square root 3, I don't want this happen. Okay, so forget about like this triangle. I want you guys to look at the small triangle here. Okay, the ACD. So if I compare the ACD with this triangle, then you could see this is 10. 10 should be equal to A square root 3. Okay, 10 should be equal to A square root 3. AC, compare the length AC with this side here. You guys okay? AC equal to A 10 equal to A square root 3. And then now we're gonna figure out the A. We divided by the square root 3 for both sides. And again, remember, we don't want any radical on the denominator. So we need to rationalize. We multiply the square root 3 over square root 3. And then you should get A equal to 10 square root 3 over 3. Okay, one more time. Only consider the triangle ADC, the small triangle here. Compare the ADC with the 30, 60, 90 triangle. You figure out the A equal to A square root 10 square root 3 over 3. Now, we can figure out the DC here. DC will be equal to A. So again, it will be 10 square root 3 over 3. Now, we want to figure out the hypotenuse, the AD. So AD will be equal to 2A. So AD equal to 2 times your A here. Simplify it. Okay. Now, we find the DC and DA. And we need to find the BD here, DB here. And we just think that like this triangle, the ABD, this is isosceles triangle because these two angle is congruent, right? This is 30 degree, this is 30 degree. So I know this side should be congruent here. BD should be congruent to AD. So I write it down, isosceles triangle. And DB will be equal to the DA. Okay. A question? Write it down on your notes. Okay, any questions for this session? Okay, so we're done for the 5.5. We have the 5.6. Segment divided proportionally. Okay, hey guys, before I start with the next sessions, let's take a break. Okay, take a 15 minutes break. Come back at 2:55. Okay. Okay, guys. You guys come back yet? Okay. Section 5.6. Segments divided proportionally. So in this figure, we have a two-line segment. The first one, this is the AC. And you can see we have a point in between. It's going to be the point B here. And then we have another line segment, DF. E will be the points in between DF and here. So we say if AC and DF are divided proportionally at point B and E, if they are in this proportion, okay, AB over DE equal to BC over EF. Okay, hey, do you guys remember what is the meaning of the proportion? Remember one of the session, the previous sessions, we talked about the ratio. I don't remember which session is it. We talk about the ratio, right? We could have A colon B, or we could write down the ratio as A over B. Ratio, we do have the same unit. Okay, ratio, we have the same unit here. And then we have the rate. Same idea is going to be A over B, but they may have a different unit. Okay, for the rate, we have a different unit. Okay, and what is the meaning of proportion? Proportion is like when either two ratio or two weights equal to each other. Okay, proportional. Proportion is going to be two ratio or two weights equal to each other. Like A over B equal to C over D. We call this is the proportion. Okay, so these sessions, we're talking about a segment divided proportionally. So we're gonna write in like this way. Like you could use the ratio AB over DE is the ratio. Another ratio will be BC over the EF. When they're equal to each other, we call this is gonna be the proportion. Okay, this is like a really simple one. Okay, we only have a few points on the line segment. Now, write it down on the notes. Okay, your notes is missing like this part, AB over DE equal to BC over EF. And then we could write it down like AB over BC equal to DE over EF. They are at the same rate. Okay, remember we could exchange like these two guys. Okay, either way, this is called the proportion. Okay, this one. I do have another two line segment, the RW, this line, and the HM. They are divided proportionally when I could write it down the proportion like this way. RS over HJ equal to ST over the JK equal to TV over the KL and VW over the LM. Okay, they're gonna compare like side by side in here. Okay, for example, like the RS is 6, and then the HJ will be 4, and then the ST will be 12, JK they're gonna be equal to 8. Okay, so we could write it down equal to each other like this way. When you simplify, they should be the same numbers here. Okay, so we could plug in those numbers here. Okay, again, copy it to your notes. When you simplify all of them, it's going to be equal to the 3/2, right? Okay, example. In the figure, points D and E divided AB and the AC proportionally. If AD equal to 4, DB equal to 7, EC equal to 6, and I want you guys try to find the AD. Okay, try to do it by yourself. Use the proportion like this part here. Okay, try to write down the formula first and then plug in the numbers. Okay, try the example 1. Okay. Okay, write down the formula here. AD over AE equal to DB over EC. Okay, you could write it down like AD over DB equal to AE over EC. Okay, you should get the same answer. Let me put it down here. Okay, you could write it, set up the formula like this way, or you could do AD over DB equal to AE over EC. Okay, either way will work, okay? And then plug in the numbers. So you have a 4 over AE equal to the 7 over 6. And then you're gonna use the cross multiplication method. So you should get 7 AE equal to 24. Divided by 7 for both sides, you're gonna get AE equal to 24 over 7. Okay, you're gonna get the same thing here. 4 over 7 equal to AE over EC, right? And then you're gonna use cross multiplication we're gonna get 24 equal to 7AE divided by 7. So AE equal to 24 over 7. Okay, we're gonna get the same answer. Okay, right? Either way, set up the formula. Okay, next one. So 7 divided proportionally. When we have the numerator denominator addition property, if A over B equal to C over D, then you could just add the C here, add it up together. A plus C over B plus D equal to A over B equal to C over D. Okay, we call this is the numerator denominator addition property. So for example, like 2 over 3 equal to 4 over 6. Well, just imagine like 2 is going to be equal to A, B equal to 3, C equal to 4, D equal to 6. So we try to apply this property. So we will have 2 plus 4 over 3 plus 6. When we calculate it, that will be equal to 6 over 9, right? And then we could simplify it. So this guy is going to be equal to 2 over 3, or we can say this is going to be equal to 4 over 6. Hey, write it down on your notes. Your notes is missing like this part here. Okay, the notes here, write it down here. This is just like the example to solve the property. Okay. Okay. Given R, W, and HM are divided proportionally at points. So we want proof. I want you guys to prove the RT over HK equal to TW over the KM. Okay. The previous slide is saying like RS over HJ equal to ST over JK. Okay, it's 1 by 1. Okay, one segment by one segment. But now I want you guys try to prove RT over HK equal to TW over KM. Think about it. I want you guys try to use the numerator denominator addition property. Okay, try to use this property for this proof. It's not like the 2-column proof. Okay, just write down the formula. Okay, using the numerator denominator addition property. First step, try to write it down this one. Rs over Hj equal to St over Kjk. Okay, we're gonna write it down the proportional formula. And then use the numerator denominator addition property. Okay. So Rs over Hj, you could equal to add up the numerator and add up the denominator. Rs plus St and Hj plus Jk. Okay, one more time. This is from the numerator denominator addition property. When A over B equal to C over D, you could say A plus C over B plus D equal to A over B. Okay, this is from the second part here. And then using the line segment addition, Rs plus St, that will be equal to Rt. And Hj plus Jk equal to Hk. Okay, so we got the first part here, Rt over Hk. And then we're gonna take care of the second part. So second one, I'm gonna use here, the Tv over KL equal to TV plus VW over KL plus LM. And then use the line segment addition property. TV plus VW equal to TW. KL plus LM equal to KM. And then you know these two guys, from the formula here, they are equal to each other. So therefore we can draw the conclusion. RT over HK equal to TW over KM. Make sense to you guys? Okay. And do you guys still remember these two properties? Right? Remember that we proved it like the previous chapters. When A over B equal to C over D. Right? They are equal to each other. So what we're gonna do, we can add 1 for both sides. Right? Add 1 for both sides. Then now we're gonna get the same denominator. So we have a B on the denominator, and on the top that's the A plus B. And this is the D, get the same denominator. So that will be C plus D here. Okay, or you could use the minus. Okay, do the same thing, but with the subtract 1 for both sides instead. So you could see if A over B equal to C over D, then A plus minus B over B equal to C plus minus D over D here. Okay, we proved this part from the previous chapters. Okay, it can be like plus or minus. Okay, film. If a line is parallel to one side of the triangle and intersect the other two sides, then it divides this size proportionally. Okay, if DE here, DE is parallel to the side of the triangle. So I can say the DE parallel to the BC. These two lines are parallel. And then DE intersect the AB at D, and DE intersect AC at E. Then we can have this proportion AD over DB equal to AE over EC. Hey, highlight this formula. Okay, if these two lines are parallel, then you could write down the sides are proportionally using like this formula. Or you could write AD over AE equal to DB over the EC. Okay, either way. Okay, AD over DB equal to AE over EC, or compare these two over these two. Okay, now example 3. Let's try to do the 2-column proof. Okay, this is the film. We try to prove this film. So triangle ABC with DE parallel to BC. And the DE intersect the AB and AC at D and E here. So prove the size is going to be proportionally like this way. So first step, remember, write it down the given information. Okay, DE will be parallel to BC. So if these two lines are parallel, what happened of the angle 1 and angle 2?
Congruent.
Yes, congruent. Angle 1 is going to be congruent to angle 2. Reason?
Corresponding angles.
Corresponding angles are congruent, right? Because these two lines are parallel. Remember the corresponding angles? The F. Remember I say remember the F. If these two lines are parallel, then these two angles are congruent. Okay, that's a corresponding angle. And then angle A will be congruent to angle A. How can we prove like the sides are proportional? I want you guys try to prove these two triangles are similar. Remember the similar triangle? We learned how to prove the triangles are congruent. Congruent means like the 3 angles, 3 sides are congruent. So we could use the CPCTC to show the other part of the angles are congruent, right? Or we can show the triangles are similar. Okay, triangles are similar. Now I want you guys try to prove the triangles ADE is gonna be similar to the triangle ABC. Okay, similar. Similar means like only the angles are congruent and then the size is going to be proportional. Okay, I want you guys try. Just prove these triangles are similar. Okay, ADE and ABC are similar. So we already proved the angles are congruent. Angle 1 is congruent to angle 2. And then how about the angle A concurrent to angle A? What is the reason?
Identity.
Identity. So we have two angles are congruent. So we could say angle ABC is similar to angle, that's a typo. Wait 1 second. ABC. ABC is similar to the angle ADD. Remember what is the reason for these two triangles are similar?
AA.
AA, good. AA, or angle. Okay, when we say the angle is AA, these two triangles are similar, we could write it down AB over AD equal to AC over AD. So if these two triangles are similar, then the sides are proportional. So AB, the whole line here, AB over AD equal to AC over AD. What is the reason?
CASTC.
CSSTP. Okay, congruent similar triangles. The sides are proportional, right? CSSTP. Okay, we are not done yet, right? We have to make it like AD over DB. Okay, AD over DB, not the AB. Then remember this formula here? We just talked about it. Like when A over B equal to C over D, then you can put like A plus minus B over B equal to C plus minus D over D. So we choose the minus here. So AB minus AD and AC minus AE. Do you have another? Give me 1 second. Guess that will be AB minus AB. AC minus. Hey, I guess that's a typo here. It should be AC minus AE over AE, right? Because of the formula, let me write it down one more time. We use like the A over B equal C over D. So we should have an A minus B over B equal to C minus D over D. Okay, so that's an AB minus AD over AD equal to AC minus AE over AE. That would make more sense. Right? We just apply like this formula. Okay. And then AB minus AD will be left with the DB here. So DB over AD equal to EC over AD. We're almost there, all right? So this is only like, you could just flip it, okay? Another form. Alternative forms of proportion. Okay, we just flip it here for both sides. Then we could get what we prove here. Okay, this is one of the forms. So I want you guys to remember that when DE is parallel to BC, so you could apply the size proportion. Okay, try the example 4. DE parallel to AB and AD equal to 10, BC equal to 6, BC equal to 20. Find BE. Okay. So these two lines are parallel. So we know the size of proportion. So we could write down DC over EC equal to over DC over AD equal to EC over BE, right? And then we're gonna plug it in. We know AD, we know DC, but we don't know EC or BE. BE, this is what we're looking for, right? So EC, that will be BC, the whole line, subtract the BE. You guys get this? EC equal to BC minus BE. Okay, plug in the numbers. And then try to use the cross multiplication. Okay, cross multiplication. So you have a 6B equal to 10 times this guy, right? And then you're gonna distribute one by one here. So you have this guy, right? Distribute the 10, 10 times 20, and 10 times the BE. Okay. So combine the 9 terms, divided by 16 for both sides. So you should find BE equal to 12.5. Okay, next one. Okay, corollary 5.6.2. When 3 or more parallel lines cut by a pair of the transversal. So remember the transversal, the T1 and T2 here. The transversal are divided proportionally by the parallel lines. So this one is talking about the P1 is parallel to P2, parallel to P3. Okay, 3 or more. And then you could see the size here, AB will be proportionally with EF, BC, and FG. Okay, so from this picture, I could say AB over EF equal to BC over FG. Okay, write it down on the notes, okay, your formula. Write it down on the notes. Okay, and make sure you guys remember this is gonna be parallel. Okay, P1 is parallel to B, P2 and parallel to P3. Let me write it down. Okay, these three lines must be parallel. And then you could find the transversal or divided proportion. Okay, write it down. And if you're done, try to do the next example. P2, not PS. Okay, P1 parallel, P2 parallel to P3. And the size is going to be divided proportionally. So try this one. Okay, use this formula. Okay, and then plug in the numbers. Try your work. And then use cross multiplication. Distribute the x, and you will get the quadratic equations. Right. And then you are gonna use the x method. So factor out 35. We can do 5 and 7, right? Factor out and set each to equal to 0. So you should find x equal to 7 and x equal to -5. Do you guys get that? Okay, x cannot be negative, right? So we reject this answer. We're talking about the distance, it has to be positive. So x equal to 7. After you find x equal to 7, find out the EF. Okay, plugging back x equal to 7, so you get EF equal to 5. Okay, right? Okay, next one. Film 5.6.3. If a wave bisects one angle of the triangle and it divides the opposite sides into two segments whose length are proportional to the length of two sides that form the bisect angle. So the CD is bisect angle ACB. And if angle 1 concurrent to angle 2, then AD over DB equal to AC over BC. Okay, compare the lines. AD, this line, over DB equal to AC over BC. Okay, talking about this straight line here. If angle 1 concurrent to angle 2. Hey, write it down here. Write it down this part on your notes. Angle 1 concurrent to angle 2, then AD over DB equal to AC over BC. Okay. Okay, try this example. Same idea. MR bisect NMP. And then I want you guys find out the X here. Try. Okay. Using here the PR over Rn equal to MP over Mn. And then plug it in. Okay, plug it in. X plus 1 over x equal to 3x minus 1 over 2x. And then use the cross multiplication method. Okay, hey, try your work and then distribute the x. Okay, distribute the x, combine the 9 terms. You should get this guy, right? And then you're gonna factor out the x. Okay, factor out the x, you're gonna get x times x minus 3 equals 0. So either x equal to 0 or x equal to 3. Okay, x cannot be equal to 0. If x equal to 0, the NR here is gonna be disappear, right? Then we only have a one triangle with x equal to 0. So we reject this one. Okay. And you guys need to know how to apply like this formula on your test. Okay. Like if I give you guys this formula, it's pretty easy. You just need to plug in the variable and solve your x. Okay. But on the exam, when you guys see those pictures, you need to remember all the proportional formula. Okay, and then see first film. Let point D be any point in the interior of triangle ABC. And then we have a EFG line on the ABC. Okay, so D will be interior, inside of the triangle. point E, point F, and point G will be on the triangle, okay, on the side of the triangle. Then we have the BE, AF, and CG. This is the line segment. They pass through the D and also the vertex. Okay, vertex A, vertex B, and vertex C. Okay. Then the product of the ratio of the length of the segment of each of these three sides. So we could write it down. When you do AG times AG over GB multiplied by BF over FC times CE over EA, that will be equal to 1. Okay. Hey, highlight this one. This is like a really special triangle for this guy. Okay, so when they multiply it, the ratio, that will be equal to 1. This is a multiplier. The dot here is a multiplier. And the line has to be passed through the point D and with the vertex. Write it down on your notes. Okay, and for the Seifert theorem can be stated in many equivalent forms. So this is one way. They just try to multiply it in a different way. It's gonna be the same thing. It's like the multiplication, you could like switch the order, right? Just like 2 times 3 equal to 3 times 2. This is the same idea. And is they say in each case we select a vertex. Also, just like here, we could select the vertex A, and the form of the product is gonna be like a set of order in the clockwise or counterclockwise. Like here, AE over EC. Okay, we're doing the clockwise. AE over EC times CF over FB times BG over GA. So you could see that's gonna be the clockwise. Or you could start with the vertex C here. So CF over FB times BG over GA in other clockwise. Or you could do counterclockwise. Okay, doing the same thing. Counterclockwise, like multiply each part here. That's it. Okay, so we're done for the chapter 5 already. And you guys have the homework session 5.5 and 5.6 due on this Sunday. Okay, if you guys have any questions about the homework, feel free to email me, or you could see me in the office hour. And then we're done for the chapter 5. We will start working on the session 6.1 this Thursday. And I'm not sure. Let me see. This week, I may postpone the chapter test 3. We should have the test 3 on April 26th, but we may. I don't think we have enough time to cover the chapter 6, so I may postpone it like maybe one more day. Okay, let's see. Okay, like,
I understand.
I'm sorry.
I agree and understand.
Finally, you're gonna take it, right? I guess if everything is on schedule, I may postpone the test on April 28th. So April 26th, Tuesday, we may do the review, okay? Review, test free, and April 28th, Thursday, we will have the test free, okay? Similar to the test 1 and test 2, I will give you guys the practice test. Okay, I let you guys do it by your own for the review for the practice test, and then we're gonna do it together in the class. Then on Thursday, we will have the test free, just like the test 1 and test 2. If you didn't do good on the test 1 or test 2, try your best on the test free, okay? You still have 2 more tests and 1 final. And log into the Canvas. I want you guys double check your grade. Let me know if you find something, if I make a mistake, anything. Let me know as soon as possible. And also on Thursday, I will cover the session 6.1. And I want you guys to get prepared. I post the construction chapter 3 and chapter 4 on Canvas. That is under the chapter 4. Okay, click on under the chapter 4. You should find the construction chapter 3 and chapter 4. Print it out. Just like last time, you guys need the tools. And then we're gonna do it together in class. Okay, chapter 3 and chapter 4 on this Thursday. And then we're gonna cover the session 6.1 this Thursday. Okay. So we done 5 chapters already. We have 4 more chapters to go. Okay, any questions? Do you guys have any questions regarding homework, your exam, your grade?
I had a question about the 2 properties that were introduced and are called, where A over B equals C over D, then A plus or minus B over B equals C plus or minus D over D. What was the name of that property?
I don't remember the name. But
Okay.
yeah, I don't remember the name, but I think we covered it in which session? From the ratio. That's 1 chapters we talking about the
In the ratio chapter?
Yes, session 5.1. Let me see.
Thank
I
you.
can find the name. I remember that should be from this session. We have, this is the like A over B equal to B over C. This is just called the geometric mean. And then we have the property 2, the alternative forms of proportions. Oh, here you go. Property 3, sum and difference properties of a proportion. Okay, we prove it. I think on the lecture. Only write down. We postpone the test. Hey guys, any questions?
Yeah, I know you might have answered this already, but for the practice ones, are those supposed to be turned in as well?
No.
Okay,
You
because
can,
on
I let you guys turn it in. I just want you guys practice the format for the exam, but that's a no credit for it.
okay, because I believe on my test 1 there was like a 100-point one, and then there was like a 0 on there. I was just confused if I had to turn in those practice tests. But again, I didn't do mine through Ontario. I did mine.
No. It doesn't count on your grade.
Oh, okay, yeah, because